Imagine you're stranded. Desert, mountains, deep at sea. You pull out your phone, and it just works. For decades, this has been science fiction. Your phone's connection has always stopped where the cell towers end. But high above us, something just launched that could finally change the rules of connectivity. This isn't just another satellite. It's a fundamental shift in how our mobile world is built. What you just saw launching into orbit is called BlueBird-6. It's a communications satellite, but on a scale we have never seen before. Weighing over 6 tons, its most critical feature is a massive, foldable antenna array that spans over 2,400 square feet once fully deployed. That's about the size of a large apartment. So why build something so enormous and send it to space? Because BlueBird-6 isn't designed to talk to giant dishes on the ground. It's designed to act like a colossal cell tower in orbit, powerful enough to send a 5G signal directly to the ordinary smartphone you carry every day. This is what makes the system so revolutionary. Think about current satellite internet. It usually requires a special dish on your roof, a bulky terminal, or even a modified phone. This new approach, often called direct-to-device or direct-to-cell, skips all that extra hardware. The satellite is so powerful, and its antenna so sensitive, that it can pick up the faint signal from your standard, off-the-shelf phone and send one back. The complex engineering happens entirely in space, so for the user on the ground, it's seamless. Your phone doesn't know it's talking to a satellite hundreds of kilometers away. It just sees a network signal and connects. This simple animation shows the concept. The satellite's beam covers a wide area on the ground, providing a connection to devices within that zone, just like a terrestrial cell tower would, but from orbit. Now, if this sounds simple, it's anything but. Sending a stable signal from a satellite moving at thousands of kilometers per hour to a tiny, low-power antenna inside your phone is an immense engineering challenge. There are 3 main hurdles: distance, power, and precision. First, the distance. A satellite in low Earth orbit is still hundreds of kilometers away, and radio signals weaken dramatically over that range. Second, your phone is designed to talk to a tower a few kilometers away, not one in space. It has a very weak transmitter to save battery. Finally, the satellite has to precisely target and manage connections for thousands of moving users on the ground simultaneously. This is why the antenna on BlueBird-6 is so huge. It needs a massive surface area to collect those faint phone signals and a powerful system to beam a strong, focused signal back down. Overcoming these obstacles is what makes this launch such a significant milestone. So, why does this matter? For those of us living in cities, the impact might not be immediately obvious. But for billions of people and countless industries, it's a game changer. Think of rural villages in developing nations where building cell towers is too expensive or geographically impossible. This technology could bring them online for the first time, unlocking access to education, banking, and healthcare. Consider the maritime industry, where ships at sea currently rely on slow, expensive satellite systems. This could provide affordable, high-speed internet across entire oceans. And in the wake of natural disasters like hurricanes or earthquakes, when ground infrastructure is destroyed, a network beamed from space could be a lifeline for first responders and survivors, providing critical communication when it's needed most. The company pioneering this specific technology is AST SpaceMobile, but they're not alone in this race. They're working with a global network of partners, including mobile network operators and even space agencies like ISRO for launch support. BlueBird-6 is a crucial step, but it's just the beginning. The real test is scalability. To provide continuous global coverage, they'll need a whole constellation of these massive satellites, all working in perfect harmony. Building, launching, and operating such a network is the next great challenge. If this technology scales as planned, the concept of a mobile dead zone might genuinely become a thing of the past. It represents a future where space isn't just a place for exploration and scientific discovery, but an active integrated part of our daily communication infrastructure. The line between terrestrial and satellite networks is blurring. From orbit to your pocket, connectivity is truly going global. Thanks for watching, and if you enjoy learning about the technology shaping our future, be sure to subscribe for more.